Guys, welcome back to TechDose, and in this video we will look at find the maximum length of valid subsequence 2 problem, which is from Leetcode number 3202. Let's now look at the problem statement. In this problem you are given an integer array nums and a positive integer k. A subsequence sub of nums with length x is called valid if it satisfies subsequence at 0 plus subsequence at 1 mod of k equals subsequence at 1 plus subsequence at 2 mod of k, and so on. This means that if you have identified a subsequence, let's say 1, 2, 3, 4, 5 is a valid subsequence from the given nums when you include all the items moving from left to right. Each of the item have two choices, whether to get excluded or included, and so there will be 2 to the power n number of choices, where n is the size of the entire array, right? So if you choose all the items moving from left to right, you will get 1, 2, 3, 4, 5, and the k value being 2. If we try to look at the adjacent items, let's say 1, 2, you take the sum of it becomes 3, and if you take mod of 2, it becomes 1. Okay, so this is giving you 1. If you consider the next window, then you are losing this 1 and you are gaining this 3. In this case, the sum will be 5, 2 plus 3, and 5 mod of 2 is also 1. Okay, now if you slide it again, 2 is lost and 4 is added, and now you will see the sum being 7. 7 mod of 2 will be again 1, and if you slide it again, then it will be 1, right? So this means when you look at a subsequence, and if on a sliding window of size 2 you apply the sum mod of k, it happens to be the same, then this subsequence will be called as a valid subsequence. Okay, so that is what is the definition. And out of all the valid subsequences, we have to return the one with the longest length. So in this example, we could have also taken 1, 2, 3 and said that this is valid. Yes, it is valid. If you take 1, 2, then the sum mod of 2 is going to be 1, and here the sum mod of 2 is going to be 1. So yes, this is valid. But if you take the length 5, then this is also valid, and length 5 is greater than 3. Therefore, 5 will be the result. We cannot have any larger length. Okay. So I hope it is clear. If you try to enumerate all the subsequences, then that will be 2 to the power of n, where n is the number of items in the array. Well, that is not a good idea to do, right? If you look at the nums length, it is 10 to the power of 3. So can you solve it in n square algorithm? N square algorithm will be 10 to the power of 6, and yes, you can solve it. And the solution idea is longest increasing subsequence, but this solution I will not be discussing here. I have already done this in my video of longest increasing subsequence, so you can consider watching that. Or otherwise, you can also try to do an nk algorithm. Nk, that is 10 to the power 3 times of 10 to the power 3. An nk algorithm can also go to 10 to the power of 6, and this is the solution that we will be doing here. Both these solutions are going to pass within 1 second definitely, because our limit is 10 to the power of 8, and if we can have operations less than 10 to the power 8, then this will definitely pass. Okay, so I hope the problem and the constraints are clear. So let's now look at some observations. Let's say that we have a valid subsequence a, b, c, d, e, f, g, h. This is a valid subsequence. Then in this case, it will follow the property that if I take two adjacent items, let's say a plus b mod of k, then the values will be in the range of 0 to k minus 1, because we are taking mod of k, right? And whatever is the value, that value will always be equal in all the sliding window of size 2 wherever I take it, isn't it? That should always be true. So let's take an example. In this example, I have taken 6 items, and since you want to calculate some mod of k, so I have already pre-computed or converted the array by using mod of k, and they will be converting to this new array. Okay, on this new array, what can be the valid subsequences that we can form? One of the valid subsequence can be 1 to 1. Why this is valid? This is valid because if you take 1 plus 2 mod of k, where the k value is 3, it is going to be 0, or 2 plus 1 mod of k is also going to be 0, right? They both are 0. And since they are all equal, there are only 2 sliding windows, right? So this will be valid. For the same reason, we have a valid subsequence 1, 0, 1, valid subsequence 1, 1, 1, and the valid subsequence 1, 1, 1, 1. So if you have solved the part 1 of this problem, part 1, then you would know that the k value was fixed to 2. K value was fixed to 2. And when the k value was fixed to 2, we can have only two cases, which was odd, even, only odd runs, even runs, or an alternating odd and even run, right? But in this case, the k value can be anything. It cannot just be fixed to 2, right? So if you look at the first two subsequences, they are alternating. Alternating in the sense that the first item and third item are same. If you had a fifth item, that will be same as well, with guarantee. And the second item and fourth item will be same. Fourth item and sixth item will be same, and so on. Okay. So that is the meaning of alternating subsequence. But there can be a case where all the items are same. Yes, why not? All the items can be same, because in this case as well, the first and the third are same, the second and the fourth are same, and so on. And why it has to be true? Because if you consider a sliding window of size 2 a b, and if you know that a plus b mod of k is going to be certain value x in the range of 0 to k minus 1, then if you slide it one time to the right hand side, then you are adding c and you are losing this a, but the b is not shifting, right? So if a plus b mod of k had to be equals to a certain value x, if you lose this a and a c is added, then according to modulo arithmetic, b plus c mod of k has to be also equals to x in such a way that a mod of k must be equals to c mod of k, right? So if you have k value as, let's say, 3, then you can say that if the mod value was going to be 0, like let's say if a was equals to 3, then 3 mod of 3 can be equals to c, can be anything, but it has to be a multiple of 3 now. It can be 9, and 9 mod of 3 will be equals to 3 mod of 3. They can be equal, unequal, it does not matter, right? So according to modulo arithmetic, the remainder when you take mod of k for a and c must be equal. Okay, so you can say that the first and third must be same, third and fifth must be same, similarly second and fourth must be same, fourth and sixth must be same, and so on. Okay, so this rule you know, right? So either you can have the same run of items, or you can have alternating, but you cannot have any other case. You can have alternating case where you have ones here and you can have whatever x is here, right? But you cannot have more than two different values in a valid subsequence. That will not be possible. Okay, when you take it with the remainder. Without remainder, it will be possible. Like if you look at this valid subsequence of length 4, it is all ones. But this was taken after mod of k, right? In the actual array, it will be 1, 4, 7, 10, which will look like they are all 4 different items, but actually they are all the same when you take it mod of k, right? So in modulo arithmetic, I am saying that you cannot have more than 2 different values in a valid subsequence. No more than 2 different values. You can have either all same or actually alternating pattern, where there will be a fixed pattern, 1x, 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 1, and so on. Okay. So since you have understood this, if you look at this point, for any number in the sequence at d, if you look at this sequence at d, let's say this was a valid subsequence. So if you look at it, then for any number in sequence at d, its previous in the sequence can be any number from 0 to k minus 1. Because if you enumerate this a, b, c, d, and if this was going to be a valid subsequence, then you know that for the previous item of d, like that this d can be anything, but what will be the value of d in modulo arithmetic? If you take mod of k, it will be in the range of 0 to k minus 1, that we already know. So d is, let's say, fixed to a single value. Then what it can assume as the previous item? It can assume any value in the range of 0 to k minus 1. Like if I take the mentioned example here, like if this was the d, okay, then what can be its previous item? Like its previous item could have been 0, or it could have been 2, or it could have been 1 as well. You could have chosen anything. So if you had chosen 0, then it will end up with the valid subsequence number 2, 101. If you had picked up 2, then it will get valid subsequence 121. And if you had taken 1, then it will end up with triple ones, right? When you go to the left hand side. So the point is, whenever you are looking at a current value, the previous, just the immediate previous one, adjacent one to the left side, can assume any value in the range of 0 to k minus 1. That is a very important observation. Okay, I hope you have understood this. Then let's look at how to generate the possible sequences. So if you consider the array given mod of k, that means from the original array I have taken mod of k values. So this was the original array which was given here, and this is the mod of k array. When I take each of the element, mod of k equals to 3. So here as well we have k equals to 3. So that is how I have calculated it. Okay, now if I take this current item, let's say 1 here, and let's call it the current item, then as I had explained, its immediate previous item can assume any value in the range of 0 to k minus 1, and whatever you assume as the previous one, like let's say you had assumed 0, then its previous cannot be having options. It will be 1 because you know that it has to alternate. The maximum it can do is alternate, or it can be straight line. It cannot do anything else, right? So if there was a 1 here, all the 1 jump size indices, or you can say 2 jump size indices, will all be the same item. So if this was 1, this will be 1, and something here will also be 1. Now let's say you had chosen the previous index to be 0. Then here will be a 1, that is for sure, and its previous will not have 3 options now. Its previous will only be 0 because you have fixed a 0 here. Okay, it will be 0. Similarly, if you pick a 1 here and the previous item is 1, this has to be 1 because the two jump size has to match. And if there was a 1 here, then the previous of this one will also be the same as 1, right? So it will be a straight line. Okay, so if the length of the valid subsequence with the previous equals to 0 is equals to 3, this means that if you had figured out that the subsequence length ending at 0 is 3, like how it can be 3? It can be a 0 1 0. It is not according to this example, but I am just assuming that if the length, that means the subsequence length ending at 0 is 3 length, it is possible with the sequence 0 1 0. Then if you append a 1 to it, then the length will be extended by plus 1. Okay, so if the length of the valid subsequence with the previous being 0 is 3, then the length of the valid subsequence with the current being at as 1, which extends this subsequence by one size, will be equal to 3 plus 1, which will be 4, right? And the subsequence will be 0 1 0 1. Similarly, you can say that the valid subsequence ending at 1 will be equals to the length of the valid subsequence ending at this one as the previous item plus 1. Because if you say that the length ending here was, let's say, 2 length, then you had 2 ones. Now if you append a 1 to it, then the length of it will be extended by plus 1, and that is why we will do plus 1. Same goes for 2. If whatever is the length ending at 2, if this was x, then that will be extended by plus 1 by appending 1 to it. Okay, therefore the length of the maximum valid subsequence ending at a given index, or you can say a given number, that is 1 here, with the current value being 1, will be equals to the maximum length that you get out of all these 3 options, 0 1 2. That means the valid subsequence with previous equals to 0, previous equals to 1, previous equals to 2. Take the max of it and add 1 to extend the length by 1. Okay, or we will also be able to represent this by using 2-dimensional array, where I will be representing as length of 1 previous will be equals to length of previous 1 plus 1. What is the meaning of length of 1 previous? If I take a 2-dimensional array and I take row number 1 and the column number previous and row number 1, then the value here, if let's say this value was x, the meaning of x is it is the longest valid subsequence ending at 1 whose previous index, that means the previous item, is prev. That is the meaning of it. Okay, so if you say that the length is equals to 3 here, like let's say x is equals to 3, then this means that if 1 was the current item and whatever was the subsequence, the length is equals to 3, then that must be equals to, if the previous item was let's say 0, then that must be equals to the previous length, right? Previous length plus 1, because this addition of 1 has extended the length by 1 time. So the previous is 0 here, and its previous, the previous of this previous, right, that will be equals to current only. It has to be 1. It cannot be anything else. According to this explanation, we know it, right? Because it has to be alternating in the worst case. If this previous was 1 as well, then everything would be 1. But if the previous is something else, like let's say 0 here, then it has to be 1. It cannot be anything. And that is why we will write as length at 1 prev equals to prev 1. Okay, so in this case, if you again look at it clearly, this is the current item. The current item assumed is 1 here. The prev item is this one. Okay, so 1 previous, the length ending at this one, whose previous is this 0, will be equals to the length ending at this previous, which is 0, and its previous, which is going to be the same as the current item, right? So whatever is the length ending at this 0, where 1 was the previous item, extend the length by 1. That is the meaning of it. So I can also write it as length at current previous equals to length at previous current. Okay, we will see more examples. Let's see. If you want to find the length, then let's see how to do that. In the first subsequence, we have something starting at index I, we have many items to the left hand side. But if I take the last part of the subsequence, it is 1 0 1 0 1. Then I can say that the length ending at the current item, that means at 1, length ending at 1, whose previous item is 0, will be equals to the length ending at the previous item, which is 0, and whose previous item is the current item, is the same as the current item, right? Because it is alternating, which is 1. Okay, and to this you have to extend it by length 1, because the length ending at 1 will be equals to length ending at 0 plus 1. Very simple calculation, right? For the same reason, if you take all the same items, nothing is going to change. If you take all the same items, then it will be like the length ending at 1 will be the length ending at this one plus 1. Simple. So I will be using the same formulation, length at current previous equals to previous current. That means the length ending at this one, whose previous item is 1 here, will be equals to the length ending at this one, whose previous item is this one, right? And to this you add 1. So length at 1 1 equals to length at 1 1 plus 1. Similarly, for this alternating version 1 2 1 2 1, length ending at this one, whose previous is 2, length 1 2 will be equals to the length ending at this 2, whose previous is 1, length 2 1 plus 1, because it is extending the length by 1. So if you consider like, is this formulation covering both the cases where you have all the items as same and the alternating items as well, then yes, it is covering. You can figure it out here. The first and the third case is the alternating case, and the second case is the straight line case where all the items are same, right? So this formulation covers both of them, right? So this is how we will be finding length. So let me show you how to track the maximum subsequence length. Let's say that this is the given array and I have calculated array mod of k and got the new array. This has been calculated for a better understanding, right? So we will be iterating each of the values one by one. So I have taken a matrix. The matrix length will be k cross k. Why a k cross k matrix is needed? So if you look at the formulation here, length at current previous, the current or the previous any value, like the any value here in this array cannot be greater than k. It has to be in the range of 0 to k minus 1. I know that because I will be applying mod of k on all the given values in the array. Therefore, all the possible values of current and previous will always lie in the range of 0 to k minus 1. 0 to k minus 1. So it can be represented all possible combination of current cross previous. This will be giving all possible combination between current and previous. This will be in the range of k cross k. That is why I will be making a k square size matrix and not any other size. Okay. Specifically, these items will be in the range of 0 to k minus 1. So if you look at the row, it is from 0 to k minus 1, 0 to 1, where k value is 2, and the same goes for the previous as well. Now let me again repeat what is the meaning of length at xy, where x was current and y was previous. The meaning of it is the value that it stores, like let's say length at xy was equals to a, then it means that a is the longest valid subsequence ending with x, with y being the previous element under modulo k. Okay, so this same thing was written as length at current previous in the last slide. So let me show you how to update the matrix using this technique. So I'll be going to the first item and I will be looking at 1. You can look at this value, or you can take this item and apply mod of k operation every time you take it. So I will take 1, and then my current will be equals to 1. What can be my possible previous item? I will be trying with all the previous item. With k equals to 2, I can have previous item as 0 or the previous item as 1. So if you choose to have previous item as 0, then the length at current and previous will be equals to the length at, that means the subsequence ending at 1 whose previous item is 0 will be equals to the subsequence ending at 0 whose previous item is 1, because the alternating values have to be same, right? So the length ending at 0 whose previous item is 1, and whatever you length get for until this point, you just add plus 1 to it, because we are extending the length by 1. Okay, so this should be the value. So length at 1 0, this one will be equals to length at 0 1 plus 1, so this is going to be 1. Okay, now what else can we do? Actually we can have the previous item as 1 as well. So length of 1, that means length of subsequence ending at 1 whose previous item is 1 now, will be equals to the length of the subsequence ending at the previous item, which was 1, and its previous item, which is the same as the current item, right, as 1, and we will be extending this length by 1, so we will be adding plus 1 to it. So at 1 1 we have 0. Okay, at 1 1 we have length 0. 0 plus 1 will be overwritten at this 1 1, so this is going to be 1. This is how the update will happen after this first value iteration. Now if you look at the next value, which is 0, then in this case you can write length of the subsequence ending at 0 with the previous item being prev will be equals to the length of the subsequence ending at prev with its previous item being 0, because it should be alternating. If 0 is the current item, its previous item can be anything prev, but the previous of this prev should be equals to 0, right? And whatever is the length ending here at prev, to this you will be adding plus 1 length. That is how it is. Now if you look at this carefully, then we are only updating the row number 0, and we are taking the values from column number 0. So row number 0, iterating for all the prev values from 0 to k minus 1 will be equals to the row being iterated from 0 to k minus 1, and the column remaining as same. This means that on the left hand side we are moving all the columns in a row, and on the right hand side we are moving in all the rows of the same column and adding plus 1 to it. So what is the meaning of this? If you try this out, then I will say that length at this 0 prev, that means I will be going for this row, okay, will be updated with the prev and column number 0. That means look at this column number 0. Length at 0 0 will be equals to length at 0 0 plus 1. That is the meaning. So you can just take here whatever is the value and just add plus 1 to this. Okay, so that will be 1. Then similarly you can see this value, it will be 1 plus 1, this is going to be 2, and you are done. For the same reason, for this 0 again you will repeat the process. Go in the 0th row and the 0th column, look at the 0th column value and keep adding plus 1. So 1 plus 1 will be 2 here, because length at 0 0 will be equals to length at 0 0 plus 1. So that is how it became 2. Length at 0 1 will be equals to length at 1 0 plus 1. So this is already 2, so no change will happen. For this 1 value, you will see that you have to iterate for this first row and the first column. So look at this value, 2 plus 1, this will be 3. Look at this value, 1 plus 1 will be 2. That's it. For this one, you will be again iterating for the first column, first row. Look at this value, 2 plus 1, this is already 3. Look at this value, 2 2 plus 1 will be 3. Okay, and you are done. Once you are done, then you have the array elements as 2, 2, 3, 3. Now out of this entire matrix, you look at what is the maximum value. Maximum value is 3. The maximum value here says that this 3 is the longest valid subsequence, which is ending at this 1, okay, and having the previous item as 1 as well. So that is the meaning of it. Or you could have also chosen this 3, where it says that the longest valid subsequence ending at 1 whose previous item is 0, okay, and its length is equals to 3. So 3 is the answer for this particular problem. I hope it is clear. Let's now look at a dry run example. So in this case, I am given an array and the k value being 3. So you know how to fill this up. I will be taking a length table of size k by k, pre-initialized with 0 values, current on the x-axis, previous on the y-axis, and the array, I will be taking all the elements one by one and taking mod of k on top of it. So if you take 1 mod of 3 will be 1. So look at this row number 1 and column number 1, and you know what to do. Column number 1's value 0, 0 plus 1 will be 1. This value 0, 0 plus 1 will be 1. This value is 0, so 0 plus 1 will be 1, right? Okay, you are filling the row by looking at the column. Similarly for this 4 mod of 3 is going to be 1. Again repeat the same process. Look at the first column and fill the first row. 0, 0 plus 1 already 1. 1 plus 1 will be 2. And then you have 0, 0 plus 1 already 1. So no change. Now you go to 2. Okay, when you go to 2 mod of 3 is going to be 2. So look at row number 2 and column number 2. So at column number 2 you have 0 here, 0 plus 1 will be 1. Here you have 1, 1 plus 1 will be 2. Here you have 0, 0 plus 1 will be 1. And you are done. For this 3 mod of 3 is going to be 0. So look at this row number 0 and column number 0. So column number 0 is 0. So 0 plus 1 will be 1. Here it is 1. 1 plus 1 will be 2. Here it is 1. 1 plus 1 will be 2. You are done. For this 7 mod of 3 is going to be 1. So look at this row number 1 and column number 1 and again fill it. 2 plus 1 is going to be 3. 2 plus 1 is going to be 3. And then 2 plus 1 is going to be 3. And you are done. Now the next item is 10. So 10 mod of 3 is going to be 1. And again you look at first row and first column. And you see this value 2. 2 plus 1 is 3. 3 plus 1 is 4. 2 plus 1 is 3, already 3. And you are done. You are done with all the items. Once you are done with all the items, what is the maximum of this entire matrix? It is 4. So here length at 1, 1 is equals to 4. This means that the longest valid subsequence is of length 4, which is ending at 1 and its previous is also 1. This means that the sequence must be all ones, right? Which is of length 4. All ones of length 4. That is the meaning of it, and I hope it is clear. Now in this case you have to created a table size of k square. Therefore the space complexity will be k square. And we are iterating for this entire array, which is of size n, one time. And while doing that, we are iterating for exactly one row and one column. That means k plus k. So this has to be multiplied with the given n. So 2 times nk. So you can say that the time complexity will be order of nk and the space complexity will be k square due to the table. I hope it is clear. Let's now look at the code. If you are someone who is looking to prepare for top product based company within a limited time of just 3 months, then we have brought for you both the DSA and the system design live interview training program. The most important feature of this program is you get a filtered and condensed structured curriculum, in-depth discussion of all the topics, and my guarantee of your understanding, one-on-one guidance with me, and live weekend classes. To know more about the training, you can WhatsApp us on this given number. In this problem, we are given the nums array and the k value. So we will be taking the length array of size k by k and the maximum length initialized to 0. And we will be iterating for each of the item in the array. We will be finding the mod of k and storing in the current. And then we will try this current item with all possible previous values, which will range from 0 to k minus 1. So 0 to less than k. And the length at current previous will be equals to length at previous current plus 1, which I have explained. And the max length will track the maximum of the entire matrix. And at the end, we will be returning the max length. This is the entire solution, and I hope it is clear. If you still have any doubt, then feel free to comment below and I'll try to help you as soon as possible. See you guys in the next video. Thank you.